Hi guys, it's Mrs. Williams, and today we're going to learn about adding and subtracting polynomials. So make sure you have your notes ready to go, that you're fit, and that you have checked your tech. Now remember, that means your tabs are closed, your electronic devices are put away, cell phones, don't answer them, headphones in if that's going to help you to focus. Okay guys, pause it if you need to get anything ready or settled, and then let's go. All right, before we actually get to the adding and subtracting polynomials in themselves, let's make sure that we all know the terminology, and that way there's no questions or confusion as we go through. So, first thing, the variables. The variables, those are the letters in the algebraic expression. Next comes the coefficient. The coefficient, that's the number in front of the variable. That's the number that's being multiplied by the variable. So there's an implied multiplication between that coefficient and the variable. Now the constant, that's the number all alone without a variable. By the way, this W/O means without, so if you ever see me write that symbol W/O, that means without. If I ever use a shorthand or notation that you're unsure of, make sure you ask me. Okay, now the degree of a polynomial, that's the highest or the largest exponent on a variable. And the term, that would be the product of a constant and a variable. Now, like terms have the same variable to the same power or the same exponent. They can have different coefficients though. So for instance, some examples of like terms would be 3x squared and 7x squared, negative 3y and 27y, 2xy squared and 5xy squared would be like terms. But let's look at some things that are not like terms. What would not be like terms? How about 2x and 3y? The x's and y's are different. 3x squared and 7x, even though they're both x's, one is x to the first, and then there's an x squared. They don't match. xy squared and 3xy, those would not be like terms either. Okay, and then there's one more here, a polynomial. That's the sum of two or more monomials. Okay, all right. Now, let's get into the adding polynomials. Now, before we add them, there's some tips here, okay? When we add polynomials, we combine like terms, keeping the exponents the same. Now, when we combine like terms, that means we're going to add the coefficients. That's the numbers in front, remember? We're going to add the numbers in front of the variables. I didn't spell that right. Okay, so highlighting like terms in the same color might be helpful to you, okay? Sometimes when I don't have highlighters, sometimes I'll underline some and squiggle. You can use circles and boxes. I'll show you different ways to do that when we're going through some examples. Now, each sign, the addition or subtraction, refers to the term that follows it. So when you're subtracting, it's referring to the number behind it. So that there would be a minus 2x, not subtracting the 3x squared. Okay. Let's see. If you are adding polynomials, and this is only for adding, you can remove any parentheses. They are not necessary. They are not necessary when you are adding. Another trick that some people like to do is you can write one polynomial under the other so that the like terms line up. They appear in the same column. They line up underneath each other just like they did. You lined up numbers in elementary school when you added them. You can do that with polynomials. And again, I'll show you that too. Okay, so let's try an example. We're going to add the polynomials 3x squared minus 2x plus 1 plus negative 7x squared minus 4x plus 5. So this is addition. So again, we don't need those parentheses. So we have 3x squared minus 2x plus 1 plus a negative 7x squared minus 4x plus 5. Now notice instead of writing plus some negative 7x squared, I just wrote minus 7x squared. That is perfectly okay. Now I'm going to look at my highlighter here. Okay, I have a couple different colors of highlighter. I'm going to use my yellow for my x squareds. I've got 3x squareds over here, and then I have negative 7x squareds over here. Okay, which would mean when I want to add them, I have 3 minus 7 is negative 4x squared. Then I go back to my highlighter, and I'm going to choose a different color this time. Let's say pink. Okay, and I choose the pink, and now I'm going to highlight my x's. I have negative 2x's, and then over here I have negative 4x's. So negative 2 minus 4 would be negative 6x. And then I'm going to get my highlighter one more time, and I'm going to change the color again. Let's go with orange this time. Okay, and I have a positive 1 here and a positive 5 here. And if I add up 1 plus 5, I get 6. And now we have added our polynomials. Okay, so now let's try number 2 here. And let's try this one a little bit differently. I'm going to write the 7x squared minus 9x. And remember, we don't need the parentheses, but I'm going to do even a little bit more than that. With this second polynomial here, I'm going to line it up underneath the first one. So I'm going to put the minus 3x under the minus 9x. I'm going to put the plus 11x squared under the 7x squared. So really, I'm grouping the like terms. And then I have minus 10. So it's going to go back there at the end. All that does is it groups the like terms for us. Instead of highlighting them, we have them grouped together. So now we can say, okay, 7 plus 11, that's 18x squared. Then I have negative 9 minus 3, that's negative 12x's, and then I have that minus 10 hanging out over there at the end. And now we're done adding those polynomials. Okay. Now, I did promise you I'd show you if I didn't have a highlighter what I would do. Let's look at that over here. So first thing, we're going to rewrite this without the parentheses. 8a minus 6a squared plus 1 plus a negative a squared minus a minus 5. So the first thing I do is I usually look for the highest power of a, which in this case is a squared. So I've got negative 6 of them over here and negative 1 of them over there. Notice how I just squiggled underneath them. What's negative 6 plus negative 1? That's negative 7, and I'm counting my a squareds. All right. Then we can say, now I'm going to just use a straight line. 8 a's, and where are my other a's? There are a negative a. What's 8a minus a? 7a. And now I'm going to circle this time. A plus 1 and a minus 5. What's a positive 1 and minus 5? That's going to be negative 4. And if you wanted, you could use boxes instead of the squiggle underlines, you know, whatever forms you want. I've used circles, boxes, triangles. It all depends on how many different sets of like terms you want. All right, now I want you to pause for a second and try number 4 using whichever method you want, the highlighting, the lining it up underneath, the trick we just did in 6. I want you to pause it, try it, and then come back once you've got it, okay? So which method did you use? I'm going to line this up 4a squared minus 9b plus a. Then I'm going to take from here, I'm going to put the 6a under here. I'm going to put, I don't have any b squared, so I'm going to put that over here. And minus 4b, I do have b's to line up here. Okay, so that gives me 4a squared. Negative 9 minus 4 is negative 13b. 1 plus 6 is 7a, and then I have a 2b squared. Hopefully you got that same answer, and if not, hopefully you understand now why it is that answer. Okay? And guess what? We're not done, but we are going to take a step forward into subtracting polynomials. Now, this looks like a lot of notes on the top, but most of it is the same exact stuff that we just wrote down about adding polynomials. The only one that's different is this first step. This is the only one that's different. This is the new step. Okay, so the new step for subtracting polynomials is first you have to distribute the negative to all terms in the second polynomial after the subtraction sign. In other words, you're multiplying everything in the second polynomial by negative 1. Now, this is very much like when you were in middle school and you did keep, change, change. You keep the first polynomial, you change the subtraction to addition, and then you change every sign in the second polynomial. Does that sound familiar? Keep, change, change. All right. And then we're going to fill in the rest of this just like we did on the previous page. I'll even put it in blue because it's exactly the same. Highlighting like terms in the same color may be helpful. Each sign, addition or subtraction, refers to the term that follows it. And you can write one polynomial under the other so that like terms appear in the same column. Okay, now let's subtract. So the first step, we have to take this subtraction and distribute it through. So I'm going to copy the first part, 5x squared plus 2x minus 12. Well, a negative makes the 9x squared a negative 9x squared. And then the negative 1 times negative 10x is positive 10x. And then the negative 1 times negative 3 is positive 3. Okay, so now let's combine like terms. I've got 5x squared and a negative 9x squared. 5 minus 9 is negative 4x squared. Then we've got 2x's and 10x's. 2 plus 10 is 12x. Then let's find our constants. We've got negative 12 over here, positive 3 over here. Negative 12 plus 3 is negative 9. Now we have our final answer, negative 4x squared plus 12x minus 9. Good. All right, let's try another one. So we have 7x squared minus 9x, because the first one stays the same. Now we're going to distribute that negative. So when we negate negative 3x, that becomes positive 3x. And then if we negate the positive 11x squared, that becomes minus 11x squared. And then if I negate the negative 10, that becomes positive 10. Now notice this time I decided to do it by lining up. Okay? 7 minus 11, that's a negative 4x squared. Negative 9 plus 3 is negative 6x. And then we have that lonely 10 all by itself. Okay, let's try another one. Let's try this one. So the first thing we're going to do is we're going to copy the first part, 8a minus 6a squared plus 1. Now we're going to distribute this negative. So if we negate a negative a squared, that becomes plus a squared. If we negate a negative a, that becomes plus a. And if we negate a negative 5, that becomes plus 5. We changed every sign. We did keep, change, change. Now, how many a squareds do we have? I've got negative 6a squareds over here, and I've got plus 1a squared over here. So negative 6 plus 1 is a negative 5a squared. How many a's do I have? I've got 8 a's over here, and I've got 1 a over here. 8 plus 1, that's plus 9 a's. And then my constants, I've got plus 1 here, plus 5 here. 1 plus 5 is 6. So notice this time I just used the different symbols. You guys get to choose what method is most comfortable for you. You'll hear me say this over and over all year. There's a million ways to get from where you are right now to the mall. Okay, I know it's straight down Carmen's Road, but there's 100 ways you could get from here to there. Are they wrong? No. Are some of them longer than others? Absolutely, but that's okay. It'll still get you to the mall. As long as you're doing a mathematically correct method, I don't care how you get there. Okay, pause it, try number 4 on your own, and then come back and see if you got it, okay? All right, hopefully you tried this on your own. First thing I'm going to do the 4a squared minus 9b plus a. I'm just copying things down. Now I'm going to distribute. So I'm going to have a minus 6a. I'm going to have a minus 2b squared. And when I negate a negative 4b, that's plus 4b. And I lined up my like terms. Okay. So I have 4a squareds. Negative 9 plus 4 is negative 5b's. 1 plus a negative 6, that's negative 5a, and then my negative 2b squared, I have nothing to combine it with. So there we are. Okay, so that's it for all our examples. All right, so we looked at adding polynomials and subtracting polynomials. Remember, adding, you combine like terms, adding the coefficients, keeping the variables. Subtraction, you have to remember to keep, change, changed, and then you follow the addition rules. Okay? Remember, don't forget to do your summary. Formulate a question for me, whether it's a question that you do know the answer to or you do not know the answer to, or if it's something you just want clarification on. And then complete your post-video Google form. All right, guys, see you next class. Have a good day.